Dear students, welcome to all of you. Numerical Practical Problem 20. Weddle's Rule, Numerical Integration by C Programming. Write a C program to compute the definite integral for the function fx equal to cos square p plus x divided by square root of hyperbolic cos px plus square root of p plus hyperbolic sin px within the limits of integration 10 degree and 40 degree, correct up to 5 decimal places by Weddle's rule using 19 ordinates where p equal to r plus 6 by 60. Weddle's rules is a closed type 7 points Newton Cotes quadrature formula and a to b integration fx dx is equal to iw plus ew. Iw is the approximate value of the integration, ew is the corresponding error term. The simple Weddle's rule formula is this: 3h by 10 fx0 plus 5 fx1 plus fx2 plus 6 fx3 plus fx4 plus 5x5 plus fx6. Here x0 is equal to lower limit of the integration a and x6 equal to the upper limit of the integration b, and the step length is equal to b minus a by 6 and error term equal to minus h to the power 7 by 140 if sixth derivative eta a less than b. And degree of precision of the Weddle's rules is 5 because this error term is sixth derivative, so this error term is 0 when fx is a polynomial of degree 5 or less. And composite Weddle's rule divide the range of integration AB into n number of subintervals by n plus 1 ordinates or nodes x0, x1, x2, xn. The number of subintervals n, this must be a multiple of 6, and they apply the Weddle's rule in the following n by 6 subintervals x0 to x6, x6 to x12, xn minus 6 to xn, and adding all these we get I, W, C, and W for Weddle, C for composite, 3h by 10 fx0 plus 5 fx1 plus fx2 plus 6 fx3 plus fx4 plus 5 fx5 plus fx6 within the for the interval x0 to x6. So first we apply for the interval x0 to x6 simply Weddle's rule, and next apply plus Weddle's rule x6 to x12 within this interval, and next and this adding all these we get the formula for composite Weddle's rules. This 3h by 10 fx0 plus fxm 5 into fx1 plus fx5 plus fx7 and so on plus fxn minus 1 plus bracket fx2 fx4 fx8 and plus fxn minus 2 and so on, and a is equal to b minus a by n, and error term equal to minus b by a whole to the power 7 840 n to the power 6 if sixth derivative eta a less than b. First to define the pi value of pi float variable constant, this equal to this, and next define the function fx, function f, the arguments are float x and float p, this power cos p plus x comma 2 divided by square root of this float variables a b h p x with one dimensional array 50 up to 50, some integer variable nir, enter the value of r, enter the lower limit in degree, this is equal to 10 degree, and upper limit b in degree equal to 40 degree, and enter the number of ordinates or nodes, this is equal to 19 ordinates here. This now n minus 1 is the number of sub intervals, so this n equal to this revised n equal to n minus 1, Actually, henceforth, this n represents the number of subintervals which must be a multiple of 6. If n is not, this n number of subintervals is not divisible by 6, then re-enter the number of ordinates such that 6m plus 1, 6m plus m is a positive integer, this 6m plus 1. So and go to the up. So here again re-enter the number of ordinates such that number of ordinates must be 6m plus 1. Now revised value of a, this is the mean radian, this pi into a divided by 180, and b equal to pi into b by 180, and this p equal to r plus 6 by 60, and because here p equal to r plus 6 by 60, and this h equal to the step length b minus a by n, and initial sum equal to 0.0, and printf this fx0, fx1, fx2, fx3, fx4, fx5, fx6, and the sum, and k equal to step counter, actually k equal to k equal to 1 for k equal to 1, k equal to 1 represents actually the interval x0 to x6, and k equal to 2, actually k equal to 2 from x6 to x6 to x12, x12, and so on, so on, and so on. And so actually k is the subinterval, this new types of subinterval where we apply this subinterval x0 to x6, apply the simple Weddle's rule, and next k equal to 1 and I equal to 0, I equal to n minus 6, I equal to I plus 6, this increment plus 6. So first x0 equal to a plus ih, so when I equal to 0, x0 equal to a, actually the lower limit of integration, x1 equal to x0 plus h, x2 equal to x0 plus 2h, x equal to x0 plus 3h, and so on, x6 equal to x0 plus 6h. And the sum, new sum equal to the previous sum, is the previous sum is 0 initially, so 3h by 10 fx0 plus 5 fx1 plus fx2 plus 6 fx3 plus fx4 plus 5 fx5 plus fx6. This is the simple orders rule, this within the interval x0 to x6. And this printf, and this printf formatting, we printf this percentage 10.6f, actually the value total number of places 10, and for decimal places we reserve 6 places here for this sum equal to the integration value. Here note that this line is very long, so we break this line by simply enter, and so this is the line continuation, this line actually, but here comma, here put comma, and then line continuation is this k equal to k plus 1, next step. So when k equal to 2, then we go to the next sub interval x6 to x12. So I equal to next 6, so I equal to 0 plus 6, that is 6. So new x0 actually x6, new x0 actually x6, new x1 equal to x7, and new x6 equal to x12. And next we apply again simple Weddle's rule within the interval x6 to x12, and the new sum equal to previous sum. Actually previous sum means the this x0 within this interval x0 to x6, the sum integration value within this interval x0 to x6, and plus new present sum is this for the interval x6 to x12. So improved sum, corrected sum equal to previous sum plus present sum equal to this, and print this, and a required value of integration is this, and correct up to 6 places of decimal. Save the program, compile, there is no error, and compile and run, are equal to say 5, lower limit equal to 10 degree, and upper limit equal to 40 degree, and number of ordinates or nodes equal to 19, which is equal to 6m plus 1 type, is equal to number of subintervals 18. 18 must be a multiple of 6, and the subinterval, first subinterval, this x0, x1, x2, x3, x4, x5, x6, and corresponding value of f, and the sum of the Weddell's rule, sum of the integration is this value of the integration within this first subinterval is this x0 to x6. Next subinterval x6 to x12, and this sum is the cumulative sum. So previous sum, that is the sum in the x0 to x6 interval, and plus sum of the interval x6 to x12, and adding them, these we get this new sum is this. And third subinterval actually x12 to x18. So the corrected and required integration is the 0.22758. And first you must check this value of this uh, r equal to 0. This answer is this r equal to 1. All are given in the description box. R equal to 0, r equal to 1, r equal to 2, r equal to 3, r equal to 4, r equal to 9. Must check these values whether you get this answer or not. And this, and thank you for watching this video.